Hello students, today we are going to discuss about periodicity in continuous time signal. So what do you mean by periodicity? So when a signal repeats after a certain interval of time, or else we can say that a signal repeats again and again after a particular period of time, is said to be a periodic signal. If it does not repeat after a certain period of time, then it is said to be a aperiodic signal. So in general, what we say, the condition for periodicity is x of t equal to x of t plus capital T. So where capital T is nothing but the fundamental time period. The fundamental time period T is also given by 2 pi by omega, where omega is the fundamental angular frequency. Fundamental angular frequency, which is measured in radian per second. And fundamental time period capital T is measured in seconds. So for example, when we say when we consider this signal, so this signal is nothing but a sinusoidal signal. So we can say that in general x of t equal to a sine omega t. So generally we use either this symbol W, or else we can use this ohm symbol for omega to represent omega. So where A is the amplitude and omega is the angular frequency, okay, and this signal is varied with respect to time t. So hence it is denoted by x of t, which is given by A sine omega t. So we can say whenever we say that amplitude is A, so here also A, here it is minus A, okay, and it repeats again and again after a certain period of time, where omega is given by 2 pi by t, or t is given by 2 pi by omega. So where the signal repeats, when you see this whole signal, it repeats, okay, we are starting from 0, this is 0 value of t, and it repeats after a time period capital T, okay. So it repeats after a time period capital T, and again the signal repeats after this duration. So we can say that at this place the value is 2 capital T. So like this the signal repeats after a certain period of time. So how the signal value will be there? At a 0, the amplitude of this signal is 0, okay, and for example, I am considering t equal to 0. Okay, at t equal to 0, when you substitute in a mathematical equation, also you will get the same answer. Okay, at t equal to 0, x of 0 equal to a sine 0, right? Sine omega 0. Sine 0 is nothing but 0. So you will have the amplitude as 0. Okay, so at time t equal to 0, x of 0 value is 0, or x of t equal to 0 is nothing but 0. And again, when you substitute here, okay, so what we get, x of capital T, because this value is 0, 0 plus capital T. What is the value at x of capital T? Again, we are having the amplitude, which is nothing but 0 only. Okay, so meaning that whenever I substitute, okay, here the value is 0. So x of capital T. Okay. So wherever you have t, you should replace it by t plus capital T. So sine omega, and again this is nothing but t plus capital T, and we know the value of t is equal to 0. Okay. So this omega is nothing but 2 pi by capital T. So T get cancelled. So you will get sine 2 pi. Sine 2 pi again it is 0. So x of t again the value amplitude is nothing but 0. Are you getting? So I'll write here x of t equal to a sine, okay, omega. What is omega? From this formula, omega is nothing but 2 pi by capital T. Already here one capital T is there. Okay, because small t value is 0. T get cancelled. Sine 2 by again it is 0. So 0 into a is nothing but 0. So we can say that when a signal repeats again and again after a particular time period, so even if we can substitute a small t equal to capital 2t also, okay, 3t also, 4t also. Similarly, in the left hand side also we can substitute t as minus t, minus 2t, okay. Wherever you substitute a particular value of capital T, the signal repeats again and again after a particular period of time. That value, that capital T is nothing but fundamental time period. Okay, so if this condition is not satisfied, okay, for example, this condition is not satisfied, then I can say that it is a periodic signal. So in simple, whenever a signal repeats again and again after a certain period of time, then it is said to be a periodic signal. If it does not repeat, it is said to be a aperiodic signal. Okay, I'll give one more example. Let us consider this signal, and it continues again in the right hand side and left hand side. Let me just denote it as x of t. Okay, and this value is 0, 1, 2, 3, 4, like this. This value is minus 1, and it continues in the left hand side also like that. Okay, for example, here also minus 2, and it continues. Okay, so whether this signal is periodic or not, aperiodic. This signal is periodic. Why? Because after a period, okay, what is the value of capital T here? After a period, capital T equal to 1, the signal repeats again. Because again after one duration, the signal repeats. Okay, so this signal is said to be a periodic signal. Okay, what about this signal? What about this signal? This is aperiodic. Why? Because here it is a step signal, here again a ramp signal, again here it is a ramp signal. Okay, so the signal does not repeat after a particular time period. Okay, so here I can say that x of t is equal to x of t plus capital T. But here this condition is not satisfied because it does not repeat after a certain time period. So this is a periodic signal. This is a aperiodic signal. Okay. Thank you, students. Thanks for watching.